Hello, I am Dr. Mohamed Rouainia from Newcastle University, and I would like to present our research on the cyclic behavior of offshore structures under extreme environmental conditions. So, the recent move towards deep water energy production has led to an increased interest in the analysis and design of anchoring systems. Including monopiles, suction caissons, plate anchors, as you can see on the figure. So these are commonly deployed to moored floating production facilities. We know that the holding capacity of these mooring systems is very important because it prevents failure and also depends significantly on soil behavior during cyclic loading. So one of our research objectives is to investigate soil behavior under cyclic loading, which is complex and involves the interaction of many physical mechanisms, including remolding of the soil during cyclic events, generation of excess porous pressure, accumulation of permanent displacement, and potentially stiffness and strength degradation of the soil. We also know that soil is naturally variable material, which can have important engineering consequences. So we are also interested in this topic, and we have developed a computational framework with spatial variability of the seabed and coupled with finite element analysis. The other aspect is the representation of environmental loading in terms of wave loads and wind. So we know, for example, the representation of ocean waves is well established fields in both practice and research. For example, the statistical information of a sea state is contained within its spectral density. So we have been using these concepts to answer the question of how these factors affect offshore foundation performance. So the aim of our research is to study that question, and to do that we use 3D finite element analysis in conjunction with advanced soil constitutive models to simulate the soil behavior under cyclic loading. We also use random field calibrated from data to assess the statistics of the response, for example, the probability of failure. And we also use stochastically generated wind and wave loading that can be applied on the structure. We are also interested in developing a framework for assessing the resilience of offshore structures to natural hazards, such as an extreme storm. So this is a combination of expected structural damage and the resources required to restore functionality of the offshore structure. So the concept is central to something called performance-based design, which we are interested in. And so that the intention here is to develop, as I said, a framework for something called fragility analysis of an offshore foundation systems during extreme environmental conditions. So we have developed that flow chart that is on the right. So it's being implemented within a numerical procedure. Another research topic that we are interested in is the impact of Scour on the capacity of floating offshore wind turbines. We have a PhD student who will be starting in September, end of this month, working on this project. And we know that Scour has a significant effect on the capacity of offshore foundations, which basically can cause a reduction of the available holding power and also risking failure. So when considering floating wind farm arrays, which will use a significant number of piles, the consequences of Scour will be significant. So in this topic, we are interested to investigate classic Scour as a result of seabed particle movements, which can create a depression around the pile. We are also interested in looking at Scour as a result of the motions of the chain in the seabed. This is sometimes called trenching. So in summary, those are the three topics that we are interested to develop during the CCP-WSI Plus project. So if you have any questions about those topics, please feel free to ask me.